Hello, welcome to yet another episode where we'll be looking at the proposed memorandum of the mathematics paper 1 for the grade 10's junior examination 2025. This paper is from Johannesburg West, and let's see what the learners in this district were expected to do in as far as this paper was concerned. So the paper is 75 marks, and it has a total of 4 questions in which all the questions need to be answered. All right, so question number 1, they are telling us that given that V is the square root of B squared minus 4AC, okay, they want us to get the value of V if A is 2, B is -1, and then C is -4. Leave your answer in the third form. So all we have to do is just substitute, okay? So meaning that V is going to be the square root of our B is -1 squared minus 4, our A is a 2, and then our C is a -4. Okay, then what we have to do is just simplify whatever is under the root sign. So that's -1 squared will be a 1. And then we know that when 4 is 16, 16 and 2, or 16 times 2, that is a 32. So it's going to be 1 plus 32. Which gives us a 33. So the answer here should be square root of 33. Okay, so that is what we have for 1.1.1. Then state whether V is rational or irrational. Now, the fact that 33 is not a perfect square, it makes the whole thing irrational. All right, so 1.1.2 is rational. Then between which two consecutive integers does V lie? So for us to get the consecutive integers, we need to look for the square numbers or the perfect squares that appear before 33 and then one that appears after. So the best one would be a 25, okay, is less root 33 and then is less a 36. Okay, then if that is correct, we need to find the square root. Okay, square root of 25 and then square root of 36. Let's do this. Okay, so we said square root of 25 and then square root of 36. So meaning that we have 5. Okay, so it's between 5 and then 6. So those are the integers between 5 and 6. Then 1.2, they want us to factorize the following fully. So whenever you're factorizing, remember you're taking out what is common. So what is common here is the x, first of all. Then we have 1 minus x cubed. Okay, but then this is a difference of 2 cubes because 1 cubed is still 1. Okay, so with that, let's change this. So we shall have x, and then this is going to be just 1 minus x, and then we shall have 1 squared, which is a 1, plus x and 1 is x, and then negative x squared will be just a positive x squared. So this should be our answer. Probably 1 mark for the x, 1 mark for that, and the last mark for that bracket. So that is how we factorize that first one. And then 1.2.2, okay, in this case, we can use the product and the sum, okay? But I'm just going to open my 2 brackets and then I do it first, okay? So for us to get 3x squared, we need a 3x somewhere, and then we need x somewhere also. Then for us to have a 6, it's possible to have 1 and a 6, okay? Then it's also possible to have 2 and a 3. Remember, both of the answer is positive, so it's possible to have both numbers to be negatives also. Okay, but since our middle part is a negative, then chances are high whatever we're looking at is negative. So let me take this combination because it will make a bit of sense for me. If I put a 3 here and I put a 2, because I know that 3 times 3 is going to be a 9, and then 9 and a 2 will be 11. I'll make this negative and negative. So that becomes the final result. Then for 1.2.3, I have to do the splitting up. Okay, this is a base of 2, this is a base of 8. I need to change it around. So 2 to the 3x minus 1 is the same as 2 to the 3x multiplied by 2 to the negative 1. Plus, we know that 8 is the same as 2 cubed, but then there is that x. So what is common here? 2 to the 3x is common. What are we left with? 2 to the negative 1, which is like a half. Plus, when you take this away, we have just 1 that is left. When you simplify this, it's just the same as 3 over 2. So 2 to the 3x into 3 over 2, something like that. Okay. Then 1.3, they want us to simplify, showing our calculations. Okay. Now we have a binomial multiplied by a trinomial. But when I look at the first terms, okay, this is a 3, this is a 9, this is a 2, that is a 4. This is a plus, this is a minus. And when I look at this middle term specifically, it's like they're multiplying these two. So this represents what we call the sum of two cubes. So what I need to do, I just need to cube the first term, and then I also cube the second term. So 3x cubed is going to give me 27x cubed plus 4y cubed must give me 8y cubed. So this is the answer. I don't need to open up the brackets. I mean, I'll still get the same thing, but for 2 marks, this is what they needed you to interpret. All right, then 1.3.2, we just need to factorize what is common because of this negative sign here, okay? So if I take out what is common here, I'll have a 3a to the top. If I remove 3 to the a, I'll be left with a 3 because of this one here. And then minus, when I take out 3 to the a, I'll be left with a 3 to the negative 1, which is the same as 1 over 3. I'm dividing this by 3 to the a, so this cancels that. Then what is 3 minus a third? 3 by 3 is going to be a 9. 9 minus 1 is going to be 8, so our final answer becomes 8 over 3. Okay, then 1.3.3. Let me put it this side. It's also 2 marks. Okay. They're telling us 5. Okay. Over, it's x plus 2, x plus 3, sorry. And then we are subtracting 3 over 2 minus x. So let's use the butterfly, or some people call it the crisscross. Okay, so it's going to be a 5 into 2 minus x minus 3 into x plus 3. We are dividing it by x plus 3 and then 2 minus x. Let's open up the top. I don't know why they gave this question 2 marks, but let's see where it takes us. So it's going to be a 10 minus 5x minus 3x minus 9. We're dividing it by x plus 3 and then 2 minus x. Okay, so this and that's going to give us negative 8. That's going to be a 1. So 1 minus 8x over x plus 3 and then 2 minus x. There's nothing common on the top that can cancel by the bottom. So this would be the answer for that particular question. Then 1.3.4. Okay. So with this, we are going to use factorization. And with the factorization of it, let's look at term by term. Okay, so with the first one, on the top we have a difference of 2 squares, meaning that we're going to have x minus 1 and then x plus 1. And then this is all over the 2x minus 3. We're multiplying it by 2. This is x squared minus 3x plus 2, which is the same as x minus 1 and then x minus 2. Okay, so factorize that. You have x minus 1 and then x minus 2. Then remember, we do not divide fractions. We multiply, change the sign to multiplication, and then take this on top. Then this must become a denominator. So we have x plus 1 down. When I look at 3x squared minus 9x, what's common is going to be a 3x. I'll be left with just a 2x minus, I think, a 3. Something like that. So this is the simplified version, and I believe that's where we're going to get most of our marks. Then the next step is the chopping part. Okay, so this chops with that one. This will chop with this one. Then x plus 1 will go with the x plus 1 here. What are we left with? We're left with these 2 and then the 3x over this one. So meaning that our final answer should be just a 6x divided by x minus 2. So this becomes the final answer of what the question wanted. All right, then 1.3.5, we're still simplifying. Okay, so let me put this on the next page. I don't know, I can squeeze it here. Yep. Oh. Let me just squeeze it here. So with this, the only technique I'm seeing is this -1. So this -1 must affect everything, or we can just divide it, okay? So we have -3x squared, y -3 over 2x cubed, and then y to the 5. Remember, -1, if I want to change the exponent to a positive, I must switch from being a numerator to a denominator. Then I can apply the laws of exponents, okay? So we have more 3's, we have more x's down, we have more y's down, okay? Meaning that our final answer is just going to be a -3 over 2. 3 minus 2, we're going to have just the 1x. Then 5 minus -3, we're going to have 8. So this should be our final answer. Okay, so that is how 1.3.5 was going to be worked out. Then 1.4 determine the numerical value of this if 9x squared plus y squared is a 13 and xy is this. Okay, so what they want us to do is open up this indirectly. Okay, so we know that this will be the same as 3x minus y into 3x minus y. When you open it up, you're going to have 9x squared, okay, minus, it's going to be a 3xy and a 3xy, which is 6xy, and then we're going to have a plus y squared. Now let me separate this according to what we were given, okay? So I'll have the 9x squared plus y squared minus 6xy. Okay, so let's do the due diligence of substituting. So 9x squared plus y squared, all of it is a 13. We are subtracting. They told us that xy is a -2. So 6 times -2. So this is a 13 plus a 12. We get a 25. So that is what the question wanted as well. So that is question number 1. Question number 2, which is the equations. So let's solve this 2.1.1. So this is a dot product, meaning that either our 2x is a 0 or x minus 3 is a 0. So in this case, x is going to be 0 or x is going to be a 3. Yeah, they need 1 mark. That's so mean. Should be 2 marks, no? Anyway, it's fine. Then 2.1.2 is a literal equation where we have to make x the subject, okay? So first step, we need to get rid of the square root. That can happen by squaring both sides, okay? So you're going to have r squared is equal to capital R squared minus 3x all over v cubed. Let's cross multiply or multiply both sides by v cubed and then by v cubed. So this cancels that. And then we're going to move this r squared that side, meaning that our overall result is going to be the v cubed r squared, okay, minus capital R squared is equal to -3x. Then divide through by the -3, okay, meaning that our x is going to be, let me just switch everything. So I have r squared minus v cubed r squared over 3. So this is what the question wanted. They want us to solve for x, make x the subject. 2.1.3. What's going on here? So let's make this as a base of 2, which is going to be 2 to the negative 1. But we have the exponent of 3x plus 1. 32 can be written as 2 to the exponent of 5. Let's introduce this exponent here, and then we drop the bases, meaning that we have a negative 3x minus 1 should give us a 5. We move the one that side, negative 3x is equal to 6, meaning that our x is going to be a negative 2. Okay, and then 2.2, can we solve for m? This is an inequality. We move the 8, So it's going to be negative 11 plus 8 is less or equal to 3m is less to 4 plus 8, meaning that this is going to be a negative 3 is less 3m is less 12. Then let's divide through by 3. We shall end up with a negative 1 is less m is less 4. So that is what the question technically wanted. And then how do we represent this on a number line? So we don't have, there's an equal sign here. Oops, ask this. Okay, so since there's an equal sign, this is going to be our negative 1. And then this is going to be our 4. So this needs to be a closed dot. And then this must be an open dot by the 4. Okay, so that is what the question also wanted for 2.2.2. 2.3, solve for x and y simultaneously. They give us one equation. Like really? All right, let's see. But we can do it. But there is only something weird that I'm seeing, as much as the examiner doesn't want to tell us what exactly they're looking for. So let's take out the negative sign here, okay? So that we create the same brackets, and then we factorize. Okay, this is the sweetest simultaneous I'm seeing. Okay, so with this, we know that this first bracket, x minus 3 is going to be a 0, or x minus y is going to be a 0. So here, x is going to be a 3. With this one, x is equal to y. So if x is a 3, meaning that y is also a 3. That's all they wanted, guys. Nah? Question number 3, which is the functions, they're telling us that the graphs of f of x, which is the parabola, and then g of x, which is a straight line, are sketched below. A and B are the x-intercepts of f. C and D are the y-intercepts of f and g respectively. K is on that, such that we have lines that are parallel. So this is parallel to that. All right. Then I want us to write down the coordinates of C and D. Where is C? C is the y-intercept. So meaning that C is going to be 0 for x, and then this 4 for y. Okay, we don't need to calculate that. It's automatic. Okay, then coordinates of D. D is the y-intercept of the graph, which is represented by this negative 2. So 0 and negative 2. All right, then 3.2, determine the length of CD. So if this is a negative 2, and then this is a 4. So we have 4 units there, and then we have 2 units there, meaning that 4 plus 2 gives us 6 units. Alternatively, get a bigger value, which is a 4 minus 2, which is a 6 as well. Ne? All right, then 3.3, calculate the coordinates of A and B. So we're seeing that A represents the x-intercept of f and g. Then B represents also the x-intercept of f. So we can use either the straight line to get the coordinates of A, or we can use the parabola to get the coordinates of both. There's no problem with that. So if I use the parabola, it's going to be something like 4 minus x squared, because we know that along the x-intercept, y is a 0, equated to 0. And then you can use your difference of 2 squares, x minus 2 or 2 minus x, and then x plus 2 or 2 plus x, meaning that x is going to be a positive 2 or x is going to be a negative 2. But now, since they want the coordinates, it's always advisable to write them in coordinate form, meaning that our A is in the positive, so it's going to be 2 and 0. B is on the negative side, so it's a negative 2 and 0. That's how we get that. And then 3.4, They want the coordinate of E, the point of intersection of the two graphs. So at this point where the two graphs are meeting, the graphs will be equal to each other, okay? Meaning that I'm going to get the graph of F, and then I'll equate it to the graph of G, okay? So negative x squared plus 4 should give me x minus 2. Let me create a standard equation and solve for x using the factorization, okay? So it's going to be negative x squared minus x. When this 2 comes that side, I'm going to have a 6 is equal to 0. Divide through by the negative. So x squared plus x minus 6 is a 0. Let's open up the brackets. That's going to be x plus 3, x minus 2. I think that would make sense, no? So either x is a negative 3 or x must be a positive 2. But we have already seen that at A, that's where the graphs are meeting, okay? So the graphs are meeting at 2 points. One where x is a 2 already, and then this one should be a negative 3. So what was the question asking for? They want the coordinate of E, the point of intersection. So if we have x as our negative 3, let's use the straight line to get the y coordinate. I'll say g of negative 3, which is like a negative 3 minus 2, which is a negative 5. So E becomes negative 3 and negative 5. Okay, so if that is correct, we need to move on. And look at for which values of x will f of x be greater than the g of x. Okay, so where do we find f to be greater than g? So let's go up and see. Where is f greater than g? In other words, where do we see f to be above g? So you see, around this area, okay, all this area, the graph of f is above, it's on top of g, okay? So we know that the x value here is negative 3. The x value here is a 2. So look at the points of intersection. So we're going to see that negative 3 is less x is less 2. As plain as that. And then we get our answers. We get our marks, we move on. Then where do we find f of x to be greater or equal to 0? So what this means that where do we find the parabola to be above the x-axis? Because this line is the line of 0. Okay, so we can see that the parabola is above the y-axis within this region, okay, between point A and point B. So we're going to go down and see that our negative 2 must be less or equal to x, less or equal to positive 2. If there's an equal sign, you include the equal sign. If there's no equal sign, you leave it out. Then where do we find the combination of the two graphs to be less or equal to 0? So in other words, for it to be less or equal to 0, it simply means that one graph should be above the x-axis while the other is below. So I'm looking at two scenarios, okay? If the f is above, the g must be below. Or if the f is below, the g must be above. So let's see. So with the first scenario, we're saying f positive and then g is negative. So where do we find f to be above while g is below? So g is below throughout, okay, up until point A. But f will be above from A up to B. So this point here is a negative 2. So between negative 2 and a positive 2. Okay, that is point number 1, negative 2 and positive 2. Okay, let's switch around and see where do we find f to be below and then g to be above. So f is below around this area, okay, and then g is above around that area. So this region is also perfect for us, okay? So x being greater than 2. So the only thing I can say, okay, is that for values between negative 2 and positive infinity, how many marks is this question? It's a 2-mark question. Okay, so it's either I express it in the form of negative 2 is less or equal to x, less or equal to 2, and x being greater or equal to 2. Alternatively, what I can also say is just like x should be greater or equal to negative 2 just once and for all. Okay? So it's either I break it down into the two scenarios or just once. All right, then 3.6, they want us to get the length of AK. Where is A, where is K? Okay, so for AK, why are they asking us this? Because I feel like we're gonna need some bit of distance formula or Pythagoras. Okay, so we say this is a 2 and 0. We got this as a negative 2 and 0. We only need to get the coordinates of K. So what we know about K is that since these lines are parallel, okay, meaning that if this is a negative 2, even the X here must be a negative 2. We only need to get the Y value of K, and of which the K is passing through the straight line, which is X minus 2. Okay, so I'll say G of negative 2, which is going to be negative 2 minus 2, which gives us negative 4. So if K is negative 2 and negative 4, our A is a 2 and 0. We can use the distance formula, okay, and say that, okay, we know that AK must be the square root x1 minus x2 squared. Y1 minus Y2 squared. So it's going to be 2 minus 2 squared plus 0 minus 4 squared. So that's a 4, and then that is a 4, which is the square root of, okay, so that is 4 squared, which is square root of 32. And then square root of 32 is the same as 4 root 2. Okay, so that is that. Alternatively, if I'm to use Pythagoras, I know that this top part here will have 4 units. And then since we say that this is a 4 negative, meaning that we also have 4 units here. So if we use our Pythagoras, it's going to be 4 squared plus 4 squared, which also becomes 16 root 32, which is 4 root 2 units. All right, so that is the end of question number 3. Lastly, question number 4. Question number 4 are telling us that the function t of x is given as this. So we know that this is an exponential graph, okay? B is greater than 0. Okay, but K cannot be a 1. Where is the K here? I don't know. X-intercept at 2 and 0. The horizontal asymptote is negative 4. Then they want us to write down the range. So when you're writing the range, you base on the asymptote. So you're going to say that y needs to be greater than negative 4. Since the b is greater than 0, it's not negative. Will it make sense though? Negative 4. What is the y-intercept? Do we have a y-intercept? We don't know yet. Okay. Let me try to, okay, they want us to write the equation of t anyway for the second part. So if I try to do the substitution, okay, it's going to be b to the x minus 4. Then let's use this point here. For y, we put a 0. And then for x, we're going to put a 2. This is minus 4. I move the 4 that side, meaning that b squared is a 4. Find the square root. So b can be a plus or minus 2. Okay, since they told us that b is greater than 0, so we're going to look at a positive. So it's going to be a positive 2 to the x minus 4. This is the equation that they want. So if the b is greater than 1, meaning that this asymptote is correct, or that range is correct. Okay, so what we needed for the equation, first replace the asymptote and then use these coordinates to do the substitution. Then they want us to sketch where can, okay, let's sketch it here. So that's your x, this is your y. So we know that this is our asymptote, which is -4. And if that's a -4, for us to get the y-intercept, x must be a 0, which is going to be 1 minus 4, which is a -3. Okay, so the graph is going to pass through -3. Let's put it there. And they told us cutting the x-axis at 2 and 0. So if this is our point of 2, so it's going to be something like that. Remember, it's an exponential. So just in that sort of direction, okay? Then 4.2. So what are they going to mark here? So they're going to mark the intercepts, they're going to mark the asymptotes, and then they're also going to mark the shape. Then sketched below is a hyperbola and then a straight line. Okay, they want us to get the value of Q. So we know that this Q represents the asymptote. Okay, and this asymptote is also the y-intercept of G. As we can see that this is the y-intercept. So Q is going to be just a 1. Okay, since this Q is also the y-intercept. All right, then they want the x-coordinates of P and Q. So P and Q, that's where the two graphs are meeting, and we're going to equate both graphs, okay? So we're going to have -16 over x plus 1 should be equated to -x plus 1. Okay, now always try to create a quadratic by multiplying through by x, okay? So times x, times x, times x, and then times x, meaning that this cancels that. -16 plus x is equal to -x squared plus another x, okay? So this is going to cancel that. Move this one that side, meaning that x squared minus 16 is equal to 0. So let's factor this. It's a difference of two squares, x minus 4 and x plus 4. So meaning that one x should be a -4 or the other x must be a +4. Now we also need to get the y coordinates, or they say calculate the x coordinates. Okay, so that's all they needed, -4 and +4. All right, guys, so that brings us to the end of this paper. Okay, so I wish you guys all the best in your preparation for paper 2. I sign out.